So I always dream to say that, is that I wanted to always to say on stage in front of all this audience, Goedemorgen, everyone. I'm very pleased to be here with you. And by the way, I'm ashamed with my Dutch because I've been living in Netherlands for several years. But you guys speak so well English, and all the audience here, I guess, speak very well English, so this is where it is. But yeah, I'm delighted to be here to talk about a little bit of AI today, and other people, all the speakers will talk about a little bit of AI. But I want also to talk about the future of AI. And I think that's the future that we need to look at as well, how we're going to improve our systems today. And I was delighted to see a big banner at the entry of this place, which is the AI brains are here. I love it. I'm sure there's a lot of AI brains. But I'm here to talk about the brains of the system, the AI systems, and are they that intelligent? So I lead R&D globally for Accenture, and we've been doing applied research for 30 years. And one thing that I've seen, obviously, I mean, I've not been leading our labs for 30 years, but 5 years. But I've studied in AI, it was in the 80s. At the time, we were already working, obviously, on convoluted neural network, CNN, for people that are familiar with it. And I've seen many AI winters, but so many progress in the last decade. And that's true. AI is absolutely everywhere in the business, everywhere in the world. We drive a lot of revenue, a lot of profit through AI. If you look at asset management, everything which is related to predictive monitoring, I'm crazy about oil and gas, Industry 4.0 and everything. There's a lot of stuff that we can do there. We talk about customer engagement. I want to give you just this one. We've been working for a tax agency, European tax agency, to drive customer engagement. And the way we do that is that people are calling CRM systems, but today's CRM system are a virtual agent. Today we can close every call, 60% of the calls, from start to finish using a virtual agent. 5 years ago, we could do only 10%. That's progress. And there's more and more that we're going to see. In fact, we've done a study, and that's an interesting study that shows that if you combine capital, human, and AI, there's a completely different productivity factor. And what it will lead, we believe, by 2035, by a big boost in economy. I'm a positive guy, and I think we should still be. And so I'm talking about $14 trillion boost in economy, 16 industries, over 12 economies, and not only developed countries. So that's a big deal. And because that's a big deal, Accenture, like many other consulting companies, are embracing AI big time. And we've been doing that for more than 20 years. And you know, at Accenture, we love formulas. That's just the way it is. We love formulas. So I share with you our formula about what we call applied intelligence. We don't want to talk about artificial intelligence. And there was the lady from Microsoft here who was just talking, and I was listening to the CEO, the French CEO for Microsoft. On the newspaper, he was saying that we should never call about artificial intelligence. Maybe call it like digital intelligence or something like that, because artificial intelligence cares of people. So at Accenture, we call it applied intelligence. It's all about result. Like R&D is all about apply R&D. And so the formula is this one. You mix a bit of data with automations and analytics, and you power that at the power of AI. And that's how basically you drive not only the vision about what should be AI or what should be applied intelligence for our clients, but how it will drive meaningful results, responsible results. And so you see all the numbers and everything. I'm not going to go through them. But I think what's interesting to see there is that, first of all, we've been, probably like many of you guys in this business for quite some time, we've seen like great progress. But I think what's important also to see is that it's all about data at the end. It's like analytics, data analytics strategy, the data strategy that you need to have at the core of your AI strategy is going to be key. In fact, there's also another study we just come up with Forbes that's been surveying like 300 people, 300 executives, and they say all over the world that they've been successful. 80% of them say they've been successful in AI because data analytics was at the core of the strategy. Okay. So the big question now is that the system that we're building today, are they that intelligent? And because I want to talk about the future, I should not say, yes, we're done. Because if we're done, then basically I can leave the stage and I'm done. And I don't think we're done. We might be reading a lot of articles and newspapers that says that systems are so intelligent that they're going to take over the planet, take over our job, take over everything. No. I'm ready to say that. Our system is still not very intelligent. And in fact, to learn about it and to understand exactly what was the initial thinking of those few people, researchers, that gathered in 1956 at the Dartmouth Summer Research Project to define what is an intelligent system. And this is what he came up with. They said we would like to build an intelligent machine. What it is that it's a machine that uses language. They can form abstractions and concepts and solve kinds of problems that are reserved for humans. And on top of that, they improve themselves. Do we believe we're there? I don't think so. And it's interesting, like the second person on the left, from the left is John McCarthy. He coined the terms artificial intelligence. So I'm here today to talk about what our labs are doing and what I will engage you to do about AI systems to build the future of AI. And this really three things, because like a keynote, you don't have much time, so you need to share like three things most of the time. And the three things I'd like to share with you is that how we build smarter systems. So what are we doing for smarter AI? What are we doing for faster AI? And what are we doing for more responsible AI? Let's get started with the first one. And so, if you look at AI at the end, AI is just not one thing. It's a set of disciplines. And the combinatorial effect of those disciplines will help to build better systems, more intelligent systems. The problem we have today is that if you look at when we talk about AI, everyone is confused because it seems that AI is only machine learning. And machine learning is just one discipline of it. For sure, they've been very successful in the last 10 years. I'll come back to that because in 1940, between 1940 and 1960, they were not so successful in machine learning, by the way. But for sure, in the last decade, they've done like great progress. Deep learning, all these things. But this is not the only thing. The reason why is that those systems, we are building classifier. We're building great classifier, and they find patterns everywhere. But you know what? They don't know what it is. They have no clue about a pattern. They don't know exactly how you connect that to a concept. Finding a cancer tumor, for example, in the body for a machine learning system, that's it. But they don't understand exactly the consequence. What we're going to be able to do about this. And so I think it's much more, and we need to think about how we drive from eventually classifier patterns and everything to other things. How we combine basically two worlds that have been always there, but disconnected at one point of time. The whole semantic world will do connectionism world. White box reasoning with black box reasoning. I want to give you an example to make it very simple. And here's the example. Everyone has a mobile phone these days, and it's pretty easy. By the way, I heard that there's 5 billion of mobile phones in this planet. Can you believe that? It looks like everyone is equipped with one, which is crazy. But I've built with my people very simple applications, and we're going to leverage virtual agent for this one. And it's a very simple example. And this one, is that I'm talking to my phone, or sending basically a quick text. This is like, I need some help because I lost my wallet. Very simple question, okay? I lost my wallet. You talk to any human being, there's going to be a lot of discussion, and they will try to understand exactly your intent. What is this question? It's like, first answer I got from a virtual agent, I'm not going to tell you the name, is this one. Let me show you your e-wallet. Great. Oh, that's going to help me much. On top of that, they should know that because I'm holding my phones, I probably didn't lose my e-wallet because it's in my phone, by the way. So it's completely stupid. And the second thing is that I don't know what you're talking about. And the third one, basically, drives me to a bunch of websites where you could buy like a very nice wallet from different websites. So what I want to explain here to you, and I hope you can understand that, is that most adults would understand, and even kids, that a wallet is important stuff. Why? Because it has important items. Items that you use for payment, items that you use for identification, all these things. And so when you're asking a question, very simple questions like this to system, it would be so cool that the system not only understand the words what you're looking for, but the concept, what it means. What's your intent? Where are you? What's the context? Are you trying to pay? Are you at the airport? You need to show your ID? What is it? So that they provide meaningful answer to you. There is a way to provide meaningful answer. It's to script everything. You know what? This is not scalable. So we need systems that reason, systems that understand. And we're not there yet. Because if we want to do that, then forget about patterns right now. We need to think about what we call domain, concept, abstraction. You remember? The Darmon guys. This is exactly what we need to come up. So what is a wallet at the end? I mean, a wallet is a container. And a container has container items. And obviously, I mean, a wallet has wallet items. And some of them are receipts, insurance card, photos, credit card, cash, driver license. The reason why we say that and why we have to explain this, it's very simple. It's that because all those items will help for a mechanism, a specific mechanism. So it could be a payment mechanism. And for this, I'm going to leverage, obviously, credit card and cash or identification mechanism. And what I would love to see is a system that understands what I'm talking about, understand my intent, and based on the context where I am, provide me with the right support that I'm looking for, not the system that we have today. So for that, we believe that future of intelligent application will require two things. Number one, inference, and the other one, the notion of what we call generalization. And that does not apply to virtual agent only. You see, in this first example, that applies also to supply chain. I would love to have a system that can basically scout the internet, understand that massive steel worker are coming, and what's going to be the impact on my supply chain for auto cars, basically, that I'm building, you know? What are the consequences? Understand the meaning of things. Same for flu infection. Let's say that there's a flu infection in your company. What's going to be the impact on the people that be on the sick leave? How are you going to be replacing them? What do you find the right substitute? A bit of generalization needs to be understood. How are you going to build a profile based on the history of the people that you know, what they've been doing, who they've been interacting with? That's what I'm looking for. So to make systems smarter, our labs are working on something that we call AGI, and I'm sure that you'll hear a lot of people talking today about artificial general intelligence, and we're looking at enterprise artificial general intelligence. And we're very humble about it. What we want to do is that we want to build more flexible processes, okay? Intelligent capabilities that enable flexible business processes through rezoning. We call that living processes. And living processes is something that we're going to be looking at. So smarter AI, this is one of the big goals that we have embraced within our labs. Now I want to shift gears, and I want to talk to you about faster AI. And let's go back to machine learning. I love machine learning. I did my first neural network on the PDP-11 VAX, believe it or not. It was one layer only. And it took like a whole week to train on very limited data. So at the end, the classifier was so-so. But what's interesting to see here is that there's a huge progress that have been made in infrastructure to help to boost basically the capability of AIs. In the 40s and the 60s, between 40s and 60s, the perceptron model was running on one monolayer neural network. A monolayer neural network doesn't do much. It will never be able to identify features, for example. We can't go to the deep learning. You need to add more layers. And that's where we are. And in fact, thanks to GPUs, graphical process units, when you can drive more parallelism processes, then we had a big boost. The GPUs save machine learning, I can tell you that, big time. And then TPUs after, with TensorFlow process unit and so forth. Now we have like hundreds and hundreds of layers and millions of neurons, basically, and transactions that work and interact with each other to do deep learning. If you look at machines themselves, look at faster AI machines, you know. And much faster. Look at this one, like DeepMind from Google. First release was AlphaGo. Lee, they call Lee because they defeated Lee Sedol at Go. And you know, in 2016, you had a mix of 1,200 CPUs, 170 GPUs, 40 TPUs. 1 year later, this is what they come up with. Improve in infrastructure and in algorithm makes that you don't need so many hardware. But the funny thing about it is that on 100 plays between AlphaGo 0 and AlphaGo Lee, AlphaGo 0 won every single play. So we believe that next generation infrastructure is going to boost as well AI, okay? And you see that today, you see our friends from Huawei, Xilinx, and everything, they're all coming up with AI accelerator. We're going to see more and more, okay? And this is something that we will combine with the existing system to boost them. But at the same time, we need to continue doing innovation. And I believe that CPU has still a long way to go. Even with Moore's law peak and everything, there's still a lot of things that we're going to be able to do with this platform because they're very agnostic. They're very versatile. We can use a lot of frameworks and use a lot of abstraction language and everything to leverage that. And then on the other side of the spectrum, that's the platform for disruption, I call it. The platform for disruption is all the quantum computing, the biocomputing, all these things. We've just started like 3 years ago a whole quantum computing practice in our labs, and I'm very pleased to tell you that we're about to have a third patent on this. Really something really crazy. And combining quantum computing with AI is probably one of the solutions. Quantum computing can help generating, for example, test data for your machine learning. And we'll be able to do a lot of things together. I don't want to say that quantum will replace conventional computer and everything, but the combination effect of the two will be really amazing. Faster AI. So I talk about smarter AI, I talk about faster AI. You can't build the most intelligent system and the fastest system without being a responsible system, because if it's not, nobody will use it. It will be denied. And I want to quote the sentence of Uncle Ben from Spider-Man: with great power comes great responsibility. And I think that's really the name of the game as well. We get all carried away by all this processing power, new algorithm, what we can do. But the core of the things that we need to build is a responsible system. And within Accenture, this is something very important. Responsible system for us means 5 new principles that we need to build our system on, and we need to encourage our clients to build our system on. Accountability, it's all about regulation, rules, how you're going to make sure that your AI system behaves appropriately in the society, because it's part of them. Fairness, how you make sure that the data you use is not biased. Very important. We have a whole lab in Bangalore, they do just this. They use GAN, maybe you heard about GAN, Generative Adversarial Network, to instill wrong data into the system, to see how it's going to behave. It's fun. You need to do that. You'll see next time you drive a car that's going to be autonomous. You better have tried that. You need to be pretty reliable. Transparency, I talk about it. Transparency is all about, you remember my black box and white box reasoning combination? Finding a pattern is good. Understanding exactly what's going to come up after that. What's the reasoning? What can we do about it? What's the intent? That's the explainable part of what's coming next. That combination is very important. We call that also explainable AI. We have a whole lab in Dublin focusing on explainable AI. And then honesty and agency. Agency, I think it's probably, I would say, people-centric at the end. This technology, and I like very much the CEO from Inspired Mind, is all about this technology is all for people at the end. This is the name of the game. All right, so I'd like to wrap it up. 3 things for the future of AI. Number 1, smarter. So I would encourage all of you to invest in AGI. Try to understand and encode your enterprise knowledge so that you're going to be able to pair it with machine learning and build more flexible business processes through AI. Faster. You need to revisit your existing algorithm. We have plenty of opportunity. We're back to the ASICs world, you know. Not the CPU, even like the ASICs world, like, you know, the application-specific integrated circuit, when we had to design and choose the chip for the specific algorithm we wanted to design. And the combinatorial effect with FPGA, ASICs, GPU, TPU, and everything will help to build basically the future systems, especially redefine what is the edge of your architecture in the car, on the platform, on the offshore platform, or wherever it is. And the last but not the least, obviously, more responsible system. It needs to be designed for it, designed at the ground. That's it. So that's what I wanted to share with you. I wish you a great event. I think it looks like with all these people, it's going to be a fantastic event. And thanks for your time.